So that's me, cybersecurity research engineer, that's the job title apparently. I work in digital security, cryptography, decentralized systems, mobile security, blockchain, etc. You get the idea. All these kinds of things. It's interesting stuff. Let me see, sorry, just going to quickly check my notes. Yeah, all these kinds of things. I don't know, I like to do other stuff as well. But I'm going to talk today about blockchain and give you a quick introduction to Blockchain 101. And I always like to start with a myth or a hype. You know, hype and myth, same thing. So there's a myth that Bitcoin invented blockchain. It's quite a prevalent one, it's quite a pervasive one, but actually it's not true. The first blockchain actually came about in 2005. Bitcoin was 2009. It was hash chains that we use to verify software source code. If you're a developer, it's called Git. Git uses a blockchain internally. You'll just not see it really. That's what the hashes are in your commits. And the second myth is that Bitcoins are untraceable because, you know, they're this evil cryptographic currency that is completely untraceable and you can do all sorts of, you know, disgusting and unspeakable things with it. So it makes a really good headline, but the fact of the matter is, it's pretty easy to trace. So it's me just tracing some Bitcoins. I think those numbers are actually measured in thousands. So 17,000 means 17 million. That's just tracing large amounts of money around Bitcoin. It's traceable. It doesn't tell you who it was, but we can come back later once we know who an address is owned by, you know, because they've had their house searched and you can find out exactly what they've been up to. And you can never delete the records because, hey, Bitcoin is completely irreversible. So every transaction is visible forever. That's a big important property of Bitcoin. And it's one to keep in mind, but it's also a fundamental principle of blockchain. So all the funds can be traced to their creation, and we'll talk more about what the actual properties of blockchain are. But this is just something to keep in mind. It doesn't directly help you identify who's involved, but once you figure them out, you know exactly what they've done. So what is blockchain? Obviously we've got a lot of people here who know what blockchain is, hopefully, but there's also a few people who don't. So let's have a quick look. Fundamentally, yeah, not a joke, it's a chain of blocks. It sounds simple, but let's just see. So there's no maths. I did say in the introduction thing on the website there would be no maths. I stand by the promise. There will be no maths. First thing we need to know about cryptographic hashes. Again, no maths. It's a number and it represents a fingerprint of the data. It's like a one-way function. So if you get something that's easy to do one way, but difficult to do the other way, then that's pretty good. So for example, if I ask you to multiply two numbers, that's pretty easy to do. But if I give you a big number and ask you what two numbers are multiplied to get to it, you're going to have some trouble doing that. It's really quite difficult to go the other way. And that's a one-way function. You can't reverse it to find the input. A tiny change to the input is also going to completely change the output. Let's take a look. So here's an example. I've got a message, and I've got a hash. Don't worry what the hash is, it's just random data. That's fine. I'm going to change the message really slightly, just a little tiny bit, and the hash changes completely. So now what I'm going to do is change the name, and again it changes completely, because we've now got a different hash, because every message has a different hash. But if I give you a hash, does anyone want to guess what that says? What's the input to that hash? Come on, I've showed you three. Anyone want to take a guess? Well, it's not. Because actually, it's blockchain Meetup Edinburgh. Point is, you can't go backwards. If I give you this, it's very difficult to go backwards. It's a computationally difficult problem to actually go backwards. And that's useful, because that means we can make a fingerprint of some data. It gives us a strong assurance of integrity. If we write down the hash, it's to convey. So here's a message. So Alice bought item X from Bob for £10. All we're going to do is we're going to put the hash of the previous block in at the bottom of this block. And we get the hash of this transaction. Here it is. Now we're going to take the next thing that's going to happen. This is going to be the next one. So David has agreed a contract with Charlie for something else. And we're going to put the previous block's hash in at the bottom of it here. That's the same as that. We're putting in the hash of the last block into the next block. By doing this, we can start to form a chain. So let's just think what's actually inside that block. That's a really simple example there. But in a block, in Bitcoin, we have one or more transactions. In a more general sense, it's a group of events or records. So when you've got more than one thing happening, you can use that. A record of events, just anything we want to put in the chain. If you get something you want to put in the blockchain, that's your event in your record. So let's build a tree. Here's a tree. I built one earlier. So what we've got here is each block is linked to the next, because each block contains the hash of the previous block. And what that means is, if we verify the block at the top with its hash, that contains the hash of this block. But this block contains the hash of this block. And we all agreed earlier that we can't easily just change the input to a hash and get something different out. That actually lets us verify everything that comes before it. So if we store just that, we can verify the entire history. So just the hash of the top block is all we need to be able to verify everything that happened before it. And you can publish that, you can write it in a newspaper, you can put it on the internet as much as you want, you can tell everyone it, you can put it on a banner and hang it off Edinburgh Castle if you want. People can verify it and be sure that what they're seeing is exactly what everyone else sees. So if we had a distributed public ledger, it's a ledger that everyone can participate in, that's all over the place, there's no one spot that it resides in. Everybody can see the transactions and the operations that have taken place, but they can also now verify it. So when you make a transaction and put something and you want something put into a block in Bitcoin, let's take a look at what happens. First thing is you transmit that to the internet through your local network. So it goes through your network to the internet, and once it gets to the internet, magic happens, and it heads along the pipes to the other computers, the other networks that are on the internet, and once it gets there, it heads off to some other computers that participate in the Bitcoin network. And once it's here, they all can see your transaction. Your transaction has now reached all the other participants of the network, and that's really important, because what it means is they can all see what's happened, and that means there's no privacy in what's happened on Bitcoin. Everyone has to be able to see it for it to be valid. So let's talk about Bitcoin, a case study. It sounds boring, I just wrote that to make it sound boring. Actually it's not, okay? So this is what we think when we see Bitcoins. Nah, there are actually no coins, not even digital coins. There is no concept of a coin in Bitcoin. Bitcoin is all about bank transfers. There's no bank, but you get the idea. So when you transfer money in Bitcoin, you're actually not taking a coin and moving it around. You're just taking an amount of funds and transferring it to another person. So there are no coins, just keep it in mind. People think that Bitcoin works by making the transaction like this. So you take an amount here from this and you pay it here, an amount here and you pay it from this. But they don't think about what happens before it. You know, the idea here is that Bob has 1 Bitcoin, he pays 0.3 over there to Alice, and he pays 0.7 back to himself. But in reality, we have to look at where it came from, because in Bitcoin, everything is spent as the result of something that came before. So to spend money, you have to know where it came from. So for example, Bob takes his salary and he gives part of it to Alice. The important part is that we know where it came from. And what this means is you get a complete record of where every Bitcoin has been, and you can trace it all the way back if you want to. So to be a transaction in Bitcoin, we need to have a few things. So we need an input transaction ID. That's Bob's salary, that's how it got to you. That's important because we need to know you're actually allowed to spend those funds. Then we need an output address and an amount. So that's the full amount of the full amount of the input has to be used unless you want to give it away. So you want to send some money to your change address. So if you've only got a transaction for 100 Bitcoin, which is a huge amount of money now, I'm just going to say it because it's funny. If you've got 100 Bitcoin coming in, then you're going to want to make sure you use all of it or you'll lose it. So you need to make a transaction back to yourself, because every transaction needs outputs. The outputs are where the money's going to end up at. If this sounds familiar to you, there's a reason. It's because it's double ledger accounting, and it's one of the fundamental principles that we've used in accountancy for a long time. You debit the input and you credit the output, and that is exactly what applies in Bitcoin. So what gives a Bitcoin some value, just as a discussion point for anyone who's not familiar with Bitcoin? Some people say it might be scarcity. Is it because there's not many of them? Well, there's lots of things there's not many of, but it doesn't necessarily make them valuable. There's only one of the snowflake that I picked up this morning, but no one was going to pay me a lot of money for it. So scarcity is probably not the only thing. A predictable and controlled supply is certainly important, it's certainly useful, but is it perhaps more because other people give it value, and that by others attributing a value to a Bitcoin, it actually in itself gains the value? It's a digital currency, it was created in essence from nothing, it is just data. There's digital work needed to mine some coins, but if someone's willing to barter or trade with it, perhaps that's what gives it the money, its value. That's certainly what I would argue, is that the reason Bitcoin has a value is because others are willing to accept it in exchange for something you want. It's a barter economy, effectively, and we can use it as a fungible form of barter. But let's jump back to the properties. So what actually are we getting with blockchain or with Bitcoin? We're getting a verifiable order of events. It means we can check the order things happened in. It gives us certainty over this. So if we have 3 blocks here, and we try and swap 2 of them over, because clearly we're up to something really super scheming. We found a way to take our money back by paying it back to ourselves. Well, there's a problem here, because if you look at this, the last block hash is now not correct. It's actually up here. So we can now tell that this change is wrong. That's not allowed. Everyone else will ignore it and reject it and say, no, you're not doing that. It also gives us a tamper-resistant history. We can't tamper with the contents of a previous record. We talked about cryptographic hashes before, that any little change will make a big change to the output. So if we take a fake block that we've changed something, we've left the same last block hash, but this block now has a different hash because we've changed something in it, well, we've got a problem, because that's not right now. And we can detect that, it gets rejected. So if we want to do anything, we need to put the right block back in place. So we can't change what happened either. So this gives us a history that we can't switch the order of, and we can't switch the contents of. It's a pretty good history. We can't forge it, we can't tamper with it. And it's globally consistent. And this is why it can be valuable and be given value and be used as a currency. Because we can all reach the same conclusions as to what's happening. We can all reach the same to this, so we can decide which direction the blockchain is going to go in. We can't go down both routes. That's not going to work, because we need to be consistent. If two blocks arrive at once, we need to figure out a solution. It's not a problem. They're quite rare, but they do happen. How do we solve this? Well, the solution is as a proof of work. The first one that's seen by most people is going to win, because they will start to build blocks on top of it. And in Bitcoin, longest chain wins. So this chain, this one here, the next block came out off of this block here. And what that means is this is the chain we're going to follow, and the other one is going to die off. But don't worry, because the transactions that were inside it are not going to be lost. We're going to add them to the queue of new things, and they'll come into later blocks. So that's fine. We're not going to lose those transactions. They will still be processed. It'll just take a little bit longer. But what it means is we're reaching a consistent view of what's happened in the past. And that's really powerful, because we can reach a consensus.
Question?
Yeah?
How does a miner know he's the first?
He broadcasts it to the network, and he sees if he gets acceptance by them accepting it into their blockchain and being the top record.
And if there's two of these sort of at a distance?
Well, it's whatever the network adopts. If the network adopts your block as being the main block, then yours is currently the head block, and everyone builds on top of it. So they will actually both appear. It's just which one the next block comes on top of. And once you get 6, that's you. The rule of the network is once you get 6 on top of it, that's you sorted. Actually, maybe 5. I think yours is included in 6. Okay. But the order really matters. If I've got £20 and I spend 15, and then I try to give 10 to Darryl, for example, he's not going to get his £10. But if I've got £20 and give 10 of it to Darryl and then try to spend 15, we're going to get a completely different outcome here, because one of these transactions is going to work and one's not. And that is why order is so important in blockchain and in Bitcoin. Because if the transaction fails, you're going to get nothing. The transaction will be rejected. And you could put that to use quite cleverly to actually steal money off people by letting them think that you've paid them the money, but then having a pre-mined block that comes before it, which you're then going to use in order to say, hey, I didn't actually spend that money, I gave it to myself. And they're tricked into thinking that. That's called a double spend attack. I'm not going to go into too many details of it, it's just worth being aware of. They are quite difficult to do, but they have been seen occasionally in the past. Just be aware of them. Wait for a couple of confirmations, so blocks on top of it. Once there's a few blocks over the top of that block, you're good. So if you're buying a beer, don't worry about it. If you're selling a house, do worry about it. So how do we create blocks? We create them with a proof of work. We've talked about creating blocks, but we've not mentioned how it's actually done. We need to do a deliberately slow task that we can all agree is just as difficult for you as it is for me. If we don't have that, then someone gets an advantage in making the blocks. And Bitcoin's about people who don't necessarily all trust each other. We need to make sure that the difficulty is equal, and therefore it's a fair challenge. And we use this to reach a consensus. We need everyone to reach a consensus in blockchain to do anything. And this is really pretty difficult, even amongst friends. So reaching a consensus on where you go to dinner or to lunch can be pretty difficult. Imagine trying to do this across about 10 million people who can't agree on basically anything. Try it with people you can't necessarily trust, because people in blockchain don't really trust each other because there's no need for them to, and they don't actually know who they are. So in Bitcoin, we use hash prefixes as a proof of work. So remember those cryptographic hashes we talked about earlier? Small change to the input, big change to the output, can go backwards. Well, if we asked you to go backwards by making lots and lots and lots of attempts at the input till you got a particular output, or a particular start of the output, that would give us a way to do a task that we can all agree is pretty uniformly difficult. It's really wasteful, though, of power and resources, but it works. It lets us all agree that this process is about as difficult for each other. Whoever's got the most computing power will win pretty much every time. I say every time, it's almost every time. There's, a randomness in the universe, etc. But if you're doing this for business, what you want to think about is perhaps a closed blockchain. It will avoid inefficiency of proof of work, but there will be issues. Bear in mind, if you build a closed blockchain, it can be much easier for someone to come along and mine on it. So you're going to need to make sure, if you are doing a closed blockchain, that you can't just apply hash power and mine. You'll need to completely close who can participate. Here's a number. This is the closest we're going to get to mass today, I promise you. Would anyone care to guess? This is a number of hash calculations in Bitcoin per unit of time. Anyone want to take a guess as to the unit of time? That's a really big number. It's I think it's 2,958 trillion or something. Anyone want to take a guess what unit of time that is?
Minute.
Minute. We got minute.
Second.
It's second. Yeah. That is the number of hash calculations taking place per second in Bitcoin. It's about 1 or 2 nuclear power stations worth of power are being used just to keep it ticking over. That's quite a lot. I think that's the big nuclear power station.
Is that the agglomeration of all of the servers doing it?
Yes. That's all the servers that are all the miners that are participating. It's now not servers that are mining, it's dedicated hardware that mines. But if you take the amount of power that's being used for that, based on the current estimations of hash power, you're talking 1 to 2 nuclear power stations, if not more. And that's quite a lot. So let's talk quickly about some uses of blockchain. So in general, when do you want to use blockchain? If you need to know the order that things happened in, and nothing ever needs to be updated or removed, that's a good time to use blockchain. But you also kind of want to have people who don't necessarily trust each other. If you don't have this lack of trust, it might be worth just using a database. Blockchain's not always the solution to everything. It's worth making sure it is the right solution to your problem, because there are issues with it. For example, it's a bit slower normally than a database, and you don't necessarily, you don't get the same performance out of writes because you have to mine blocks. But any other time, probably best not to use blockchain or to look at alternatives first. It's not always going to be the silver bullet to your problem. Let's talk quickly about contracts though.
Excuse me.
Yeah?
So you were just saying there in terms of other applications,
Mm-hmm.
where does the mining come in another application using a blockchain?
So if you've got an application running on a blockchain, the application is going to produce blocks, produce data that's going to end up in blocks, okay? You need the mining in order to approve the next block. If you're building a completely private application, you don't need to use mining, you can do it another way.
So don't you just need the hash of the block to produce the next one?
Yes.
Mining the generation of that hash.
Mining is the changing of a random number inside the block to make it meet a certain set of rules. And these rules are to make it fair who makes the next block. If you don't care about that fairness in who makes the next block, you don't need to worry. If you do care about the fairness, you need to make sure that it's equal opportunities to make the next block. So only if you're allowing the public to mine do you have to worry about that. So to look quickly at contracts, I don't think there's any lawyers here necessarily, but there might be on the internet. But we'll talk about contracts because they're fun. A public ledger of all agreed contracts would be quite useful because nobody can tamper with them. But there's a problem, because if everyone can see the contract, then everybody knows the prices we're charging everyone else, and that's not necessarily ideal, because sometimes you might want to give someone a wee discount and mates rates kind of thing. But what if we could do partial commitment, so we could prove after the fact what we'd agreed upon, but without necessarily having to put the entire contents out there, so everyone can see that someone's getting a better price than someone else. Another use would be patents. You don't necessarily want to disclose what's there, you just want to timestamp it. If something's in an old block, you know it existed at that point in time. The blockchain advances at about 1 block every 10 minutes, and it recalibrates itself so that it does meet that time. But where next? Smart contracts could be quite useful. I'll tell you how to do that in a second. Self-enforcing contracts that are automatically enforcing. It could speed up doing business. You could link together your deals. You could take transactions and make them happen at a certain point in time based on other conditions that are happening somewhere else. So really quickly, a contract can have a balance of funds. This could be some kind of property or token. When you run it, rather than having a private key, we run the contract code and we pay out the funds if the conditions are met. Otherwise, we don't do it. Imagine a safe that's got a coin slot on the top that you can put coins and money into, but you can't get it out till the safe decides to open. That's effectively a smart contract. But the risks are you've got to get it perfect first time. You can't edit the contract once it's made. So fail fast, fail often, the mantra of a lot of startups. Please don't apply it here because you'll end up losing a lot of money. In fact, Ethereum, which is a kind of big smart contract platform, their valuation had a little bit of a nosedive because there was a small incident where somebody managed to steal quite a lot of money. And you know, standard trading graph here, price across the top, volume across the bottom. Oh look, lots of volume, big price crash. Big hack, a big mistake in the contract, and you know, it caused a lot of trouble. Be very, very careful if you're making smart contracts that you can't edit. In terms of scalability, Bitcoin can handle 8 transactions per second globally. That might change with some of the changes that are coming through, but it's not likely to grow rapidly. MasterCard and Visa can do 2,000. Keep it in mind. It's a lot slower than necessarily other systems, so you don't get the same performance. And in terms of the size of the blockchain, these are gigabytes down the left-hand side, sorry, megabytes. It's now, the blockchain is now, well, it was 59 gigabytes a year ago, it's now 103 gigabytes today. It's grown 7 gigabytes since the 1st of January. It grows really quickly, you can barely fit this on your gold standard SSD. That makes it much more difficult to participate, and it means it's going to end up more centralized because people are going to rely on storing it on a server rather than their own PC. Again, just want to be careful of because it keeps growing and it's difficult to get rid of the history. In terms of security of funds, your funds are only as secure as your private keys. It sounds fairly sensible, but just keep it in mind if you are encouraging users to use it, your reputation is only as secure as your keys as well. But if somebody loses their keys, how do they get their money back? The answer is they can't really, unless you've done complex things with multi-sig or similar. There's usability challenges, keep that in mind for your users, look out for them. We want people to be able to use the technology without encountering, oh, I've lost all my money, I've lost my life savings because I can't remember my password. It's a tricky problem, but it's one that's going to need solved. In terms of private blockchain, I mentioned them earlier, but there's limitations for some use cases. Making your own is possible, but you know, keep it secure. Just to go back to a point there, because I think the slide has been taken out, if you do want to do partial commitment, what you do is you put the hash of something in the blockchain. And anyone can verify the hash is correct, but they can't work out back what the contract was. So if you've got a contract, you put the hash of the contract in the blockchain, and you can come back and show it was agreed upon because here's the hash of it, but otherwise no one can tell what the terms were. So it's a good way to do that and to get a timestamp. So in conclusion, just a quick rattle through these. Number one, security. I'm a security engineer, I have to say it. Blockchain's a means to an end, but it's not the end itself. Get your implementation. If you're doing anything fancy, get it reviewed by experts. Once it goes out into the public, it's really easy to attack. There are lots of people out there who love nothing better than to break the thing that you have put your heart and soul into. They will do it, they will find a way, they're ingenious, and they don't get bored very easily. So be careful, get it reviewed by experts. Come on, chat if you want to talk about this sort of thing. In terms of trust, Bitcoin trusts the financial system without trust. It's looking at ways that we can start to displace the trust from where we normally have it in a transaction and put it in other places. We can displace the trust, but remember, our business processes are generally based on trust. Keep that in mind. Most of the world is analog and based on trust. Rome wasn't built in a day. Take it a small step at a time. Some building blocks. It's a building block for complex services. You can build all sorts of cool things on top of blockchain. If you need to stop data being tampered with and you need to keep it in order, blockchain's probably right for you. Otherwise, take a look at a database. I'm not here to sell a particular technology. A database might give you better performance and be a bit easier to use. Scalability, think about it. Bitcoin can't currently scale. If you need to make loads of transactions, either look at the Lightning Network, which is coming out soon in Bitcoin, or look at other solutions. Be cautious of designing a committee though. Just because it's complex and lots of people agreed, doesn't necessarily make it the best thing. And again, security, yes, again. Moving to blockchain technology is not a small change, it's a really big, it's almost a step change actually. Think about the GDPR, a big important piece of legislation is coming up in the future. This is going to bring serious fines for public bodies and businesses. Be very careful of their definition of personal identifying data. It's pretty broad, it can cover all sorts of things. Be very careful about this if you're building anything that people are using. And beware of the hype though. Lots of people will be out there to sell you blockchain as a solution to your problems, to do very expensive consultancy for you, that sort of thing. Blockchain's a really cool technology, but it's not perfect. It has its limitations. Make sure you're aware of the limitations and keep them in mind. Don't be fooled by hype. If anyone's got any questions, I'd be more than happy to take those.